Okay, so this is a converging lens diagram. So what we're going to do is we have a object over here, and that object has a distance known as P from here to the center of the lens. Okay, we're going to draw our first line. I'll just go ahead and use green, that would be great. First line you draw with the converging lens, you go parallel to the principal axis, and then through the positive focal point. Positive focal point's on the right side because that is where we expect light to travel through. Since it's a clear lens, we expect it to come through this way. Okay? Alright, and again, that is line number 1. So line number 2, let's use red. Red's great. Okay. On line number 2, we'll start at the same place, go through the negative focal point on the left side, okay, and then parallel to the axis. Okay, now where those converge, that's where we're going to have our object form. It is going to form right here. Okay, but just to double check, we'll do a third line. In fact, that third line, we can go ahead and just do a ray because it goes straight through the center point of that lens and should converge at the same place. Okay? So then what we should end up with is an inverted object or image that looks like the object. So right there. And the reason we put the base on where we do, I'm going to go ahead and move this over just a little bit so it's where it should be. The reason we put the base here is that we have the lines start at the same place where we did over here, and if we have the base on the principal axis here, the base is going to be on the same principal axis. That allows us to draw it real easily. Okay, and so that right there was line 3, and the red we had was line 2. You really only have to have 2 of the 3, but it works out. Okay, now one of the things we notice is that it's inverted. Okay, so that's one part we know. We know that the image is inverted. Okay, I'm just going to say that the image is, first off, inverted. It's upside down. Secondly, if you look at the size of this compared to that, we know it's reduced or smaller. Another word for that is diminished. Finally, the last thing that we notice is that it's in front of the lens, which is where it should be because light should be passing through. Okay, because it's in front of the lens over here on this side, the positive focal point side, it is real. Okay, so real, reduced or diminished, inverted. Okay, now we're also going to do a little bit of math with this. We're going to take and show you the solution on how to solve for these things and to prove mathematically that it's inverted, reduced, and real as well. And that's going to be using the thin lens equation, or the same equation we use for mirrors, 1 over P plus 1 over Q equals 1 over F. Okay? Alright, I'm going to pause here for a minute, and then we'll be back here in just a second. Okay? Okay, so we're going to start back here, and I kind of have this cleaned up a little bit so we can use it. But yes, we are going to use the thin lens equation or mirror equation that we've used before, and that's 1 over P plus 1 over Q equals 1 over F. Okay? And let's review just a little bit. You remember that P is the distance between the object and the center point of that lens. So this first green line I drew right here, the distance on that would be about 2.5 inches. Okay, just scaling the way I did, it's close. Okay, all right. This other, or the focal points that we're using, um, and I'm approximating those at about 1 inch. Okay, so if we were to take and put them in these equations, then we have 1 over 2.5 plus 1 over q equals 1 over, there we go, 1 over f. Okay? Alright, so, which is 1 over 1, right? Alright, and again, that's a 5. Okay, so 1 over 2.5, that's 0.4 plus 1 over q equals 1. So to isolate q, then, we have 1 over q equals 1 minus 0.4. So that's 1 over q equals 0.6. We take and solve algebraically. We get that that's going to be equal to, that q is going to be equal to about 2/3 of an inch, or 0.67, right? Actually 1.67, sorry. 1 2/3. Okay? Alright. And so if we were to measure this out from the blue to the lens, so that red line, that red segment right there, that would be about 1.67 inches. Okay? And that looks about right as compared to if this is an inch and the next dot is a full inch. Looks like about 1 2/3. Okay? So mathematically it looks like the diagram confirms what we have. Okay? The next thing we'll do is we'll do magnification. Magnification is equal to negative q over p as the equation, just like we had for mirrors. Okay, so if I said negative 1.67 divided by p, which was 2.5, that comes out to about 2/3, right? Okay, so if this is about 2/3, then that means this would be about 2/3 of that size, and that looks about right. Okay, but the key thing here, one of the key things we need to notice is this is negative. That's what tells us it's inverted. The negative value on the magnification is going to tell us that it's inverted, because that comes out to just like I said, about negative 0.67, about negative 2/3. Okay, that is what's telling us that this is a inverted object. Okay, the 0.67 itself, being smaller than 1, tells us that it's reduced in size. So we have the negative means it's inverted, it's reduced or diminished, and lastly, we still know, because of its location over here on the positive focal side, that it is a real object, and converging lenses produce real objects. Okay? Alright, so that's a converging lens. Thanks, good luck.